Welcome. We're diving into something that's, well, it's pretty crucial to, just about everything we do online.
Mm.
Network security.
Yeah, network security.
And what we want to do today is really unpack all of it.
Absolute.
So that, we understand not just the what, but also the why behind all these technologies that honestly, most of us just take for granted every day.
Right. It's easy to just click accept and move on with our lives.
Yeah, exactly. We're not going to get too lost in the super technical weeds.
Of course not.
But I think, our listeners are curious and they want to understand at least the essential stuff, right?
Absolutely. A good foundational understanding.
Yeah, yeah. So we'll be focusing specifically on firewalls today,
Mm-hmm.
and also how they play a role in segmenting networks, which we'll talk more about.
Right. Creating those secure zones.
Exactly. And then we'll touch on VPNs, which, a lot of people are familiar with,
Definitely.
at least in name, but maybe not exactly how they work. And then this more modern concept called SASE.
Yes. SASE. Definitely a buzzword in the industry these days.
It is. It is. Okay, so let's unpack all of this, starting with firewalls. I was really struck by this idea that a lot of our digital defenses are based on real-world security concepts.
Oh, absolutely. It's all about taking those tried and true principles and applying them to the digital world.
Right, right. And firewalls are a perfect example of that, right?
Absolutely. The term firewall itself, it comes from those barriers you see in buildings, between townhouses. Their purpose is to contain a fire.
Right.
Stop it from spreading.
Yeah.
Buy time for, emergency services to respond.
Exactly. Exactly. And so in the digital world, that fire we're talking about is, well, it's a cyber attack.
Exactly. It could be malware spreading through a network or an intruder trying to gain access to sensitive data.
Right, right. So we're basically building these
Yeah.
digital walls, right,
Precisely.
to protect our systems.
Yeah. This sort of foundational setup, right? Where we've got firewalls guarding both the connection coming into our network from the internet, but then also firewalls within the network itself.
Okay, so multiple layers of firewalls.
Exactly. Defense in depth.
Got it.
And at a basic level, a lot of these firewalls, they use a technique called packet filtering.
Packet filtering. Okay, so what exactly is packet filtering? I mean, is it literally filtering packets?
Well, imagine it like this. Imagine every piece of data traveling across the network is like a letter.
Okay.
It's got an envelope, right?
Right.
And on that envelope, you've got the sender's address, the recipient's address,
yeah.
and maybe some other information.
Okay.
So packet filtering is like having this digital border agent who inspects every single envelope, looking at that basic information to decide whether to let it through or not.
So what kind of information are we talking about specifically?
Well, the sources mentioned the origin address, where the data is coming from, the destination address, where it's going.
Right.
Then there's the port number.
Port number.
Yeah, it's like an apartment number within a large building, the IP address.
Okay.
It tells the receiving computer which application the incoming data is for. So is it for your web browser? Is it for email? And so on.
Got it. So different applications have different port numbers?
Precisely.
Okay. So how does the firewall actually use this information to decide what to block and what to allow through?
So, for example, standard web browsing, that usually happens on port 80.
Okay.
Secure web browsing using SSL or TLS, that often uses a different port.
Right.
So a firewall using packet filtering can be set up to say, okay, we're going to allow traffic on these ports because we know it's probably legitimate web traffic. But then it can also block traffic based on the source address.
Okay, so how does that work?
Let's say you have a rule in your firewall that says, don't accept any traffic that claims to be coming from within our network if it's actually coming from outside.
Right.
This is about preventing what we call spoofing, where an attacker tries to disguise their traffic as if it's coming from a trusted source.
So it's someone trying to sneak into a party by pretending to be on the guest list.
Exactly. You don't want to let your guard down just because something appears to be internal when it's actually coming from the outside with bad intentions.
Makes perfect sense. And then there's the destination address too, right?
Right. So for instance, you might configure a firewall to only allow traffic to your web server and block any attempts to directly access your database from the internet.
Ah, okay. So controlling which systems are exposed to the outside world.
Precisely. You want to minimize your attack surface as much as possible.
Right. And this actually brings us to that second internal firewall that you mentioned earlier, right?
Yes.
The one inside the network. So what's the real benefit of having that like extra layer of protection?
Well, it goes back to this idea of defense in depth.
Hmm.
Not relying on a single point of failure.
Right. Right.
So let's say, for instance, that your first firewall, the one facing the internet, gets compromised somehow.
Okay.
Well, that internal firewall is still there as a backup, providing that crucial second layer of defense.
So even if an attacker gets past the first wall, they still have another one to deal with.
Precisely. It significantly reduces the chances of them actually getting to your most sensitive data.
Makes sense. Now, the information you shared, it goes beyond this idea of just examining the envelope, right?
Right.
Of the data packet. It talks about something called stateful packet inspection.
Yes, stateful packet inspection. It's a step up from basic packet filtering.
Okay, so how does that work?
Well, with stateful inspection, the firewall actually keeps track of the entire conversation between two devices.
Okay.
It remembers the sequence of packets. It looks at the context of the communication. It's not just about checking individual packets in isolation.
Right, right. So it's like instead of just glancing at the to and from on an envelope, you're actually opening it up, reading the letter, and remembering previous letters in that conversation.
Precisely. It's about understanding the flow of the communication.
Okay, so why is that important? Why do we need to look at the entire conversation?
Well, sometimes a series of data packets might seem perfectly harmless when you look at them individually.
Okay.
But when you see them in the context of the entire exchange, you might realize, hang on a second, this looks like a multi-stage attack.
Ah, I see. So stateful inspection allows us to catch those more sophisticated attacks that might slip past a basic packet filtering firewall.
Exactly. It's about connecting the dots.
Got it. Application firewalls.
Yes, application firewalls, another layer of defense.
So how do they differ from these packet filtering and stateful inspection firewalls?
Well, they go even deeper. Instead of just looking at the header information, they actually inspect the contents of the data packets.
Mm-hmm.
They look for specific patterns, known malware signatures, or even anomalies in the data that might indicate an attack.
So it's like not just reading the letter, but also analyzing the language, looking
Right.
for suspicious phrases or attachments.
Exactly. And they can be very specific to certain applications, like a firewall designed to protect your web server from SQL injection attacks.
Okay, so it's about providing more targeted protection for different applications.
Precisely.
Got it.
Yeah.
Now let's move on to what exactly are they and how do they fit into this network security puzzle?
Think of a proxy as a middleman.
Okay.
It sits between your computer and the server you're trying to access.
Right.
So instead of your computer talking directly to, say, a web server, it talks to the proxy.
Right.
And then the proxy communicates with the web server on your behalf.
Interesting. So why do we need this middleman? What's the benefit of adding this extra step?
Well, it offers a couple of advantages. First, it allows for inspection of the traffic before it reaches its final destination.
Okay.
So you can scan for malware, you can filter out unwanted content,
Right.
and it can also provide a degree of privacy
How so?
because the web server only sees the proxy's address, not your computer's address.
Ah, I see. So it's like masking your identity.
Exactly.
Okay. Now, there's this other thing, NAT, that you mentioned, network address translation.
Right, net.
It's probably running on everyone's home router right now,
Most likely, yes.
but they probably don't even know it.
It's one of those things just works in the background.
Right. So can you
Yeah.
explain like what it does and why it's important for security?
Sure. So the internet uses these public IP addresses that are routable across the entire network,
Right.
but we also have private IP addresses, non-routable ones, that are commonly used within internal networks,
Okay.
like your home network.
Got it.
So NAT is what translates those private addresses to a single public address when your devices need to talk to the outside world. It's kind of like having a main phone number for your whole household.
Yeah.
When someone calls that number, the person answering can then direct the call to the specific person inside.
Right. Right. So NAT allows multiple devices on my home network to share that single public IP address.
Precisely.
Okay. But where does the security aspect come in?
The security comes from the fact that your internal private addresses are hidden from the outside world. Someone on the internet can't directly initiate a connection to a specific device inside your network because they don't know its private address.
Right.
And NAT prevents that direct access. It's a basic but essential security feature built into most routers.
Got it. So we've talked about firewalls, proxies, NAT, all these different ways to protect our networks.
Right.
Now, let's move on to this idea of network segmentation, creating these like safer neighborhoods within a network.
Segmentation, yes. It's about adding layers of protection within your network.
Right. Different models, starting with the Bastion host.
Yeah, the Bastion host.
Okay.
A classic, but not necessarily the most secure approach.
Yeah, it was described as kind of an early and not really recommended anymore approach.
Right.
So what was the thinking behind the Bastion host?
Well, the idea was to have a single server, like a web server, that sits directly exposed on the internet,
Okay.
with maybe just a single firewall in front of it. And the goal was to prevent the entire internal network from being directly accessible.
But it sounds like putting all your eggs in one very vulnerable basket.
That's exactly the problem with the Bastion host model. That single server becomes a prime target.
Right.
And if an attacker compromises that one machine, well, it could potentially become a gateway to the entire internal network.
So a single point of failure.
Exactly.
Got it. And then we moved on to the tri-homed network model.
The tri-homed network.
So what was the idea behind that one?
Well, this one involved a single firewall, but with 3 network connections.
Okay.
One to the internet, one to the internal network, and a third to a demilitarized zone, or DMZ.
A DMZ.
Which is basically a zone where you put your public-facing servers.
Ah, okay. So like a buffer zone between the internet and your internal network.
Exactly.
Okay. And what were the weaknesses of that approach?
Well, having a single firewall trying to manage all that traffic, it's complex, and it's still a single point of failure.
Right.
If that firewall gets compromised, you're in trouble.
Got it. So then we get to the basic DMZ model.
The basic DMZ, this one's much more robust
Okay.
because it utilizes 2 firewalls.
2 firewalls. Okay, so how does that work?
Well, you have one firewall protecting the DMZ from the internet, and then a second firewall protecting the internal network from the DMZ. So you've got those clear zones, the untrusted internet, the semi-trusted DMZ, and the trusted internal network.
So even if an attacker gets past the first firewall and into the DMZ, they still have to get past another firewall to reach the internal network.
Exactly. It's that defense in depth principle in action.
Got it. And then we have the multi-tiered DMZ.
The multi-tiered DMZ, taking it to the next level.
So how does that one differ?
Well, it's basically taking the basic DMZ concept and expanding it.
Okay.
You add even more firewalls to segment different functions within the DMZ itself. So you might have a firewall separating your web servers from your application servers.
Okay.
And then another firewall separating the application servers from your database servers.
So like creating even smaller, more isolated neighborhoods.
Exactly. It's about limiting the blast radius, so to speak.
Right, right. So if one area gets compromised, it doesn't necessarily mean the whole network is compromised.
Precisely. It's much more granular control and security.
Got it. Now, let's shift gears and talk about VPNs.
Virtual private networks.
Yeah. A lot of people have probably heard of VPNs. They might even use one.
Definitely.
But do they really understand what they do and how they work?
That's a good question.
So what is the fundamental need that VPNs address?
Well, at their core, VPNs are about creating a secure, encrypted tunnel for your data to travel through the public internet. The internet isn't inherently a trusted network.
Right. Anyone could be snooping on your traffic.
Precisely. So a VPN establishes that secure channel, so your data is protected even when it's traveling over untrusted networks.
Okay, and how do they create this secure channel?
By encrypting all the data that passes through the tunnel.
Encryption. Got it.
So even if someone intercepts your traffic, all they see is gibberish.
Right. They can't read it without the decryption key.
Exactly.
Now, this encryption, while it provides security, also introduces a potential challenge.
That's true. It's a bit of a trade-off.
So what's the downside?
Well, because the data is encrypted, it becomes much harder to inspect it for malicious content.
Ah, I see.
So while it protects your communications, it can also make it easier for malware or attacks to slip through undetected.
Right, because the security tools can't see what's inside the encrypted traffic.
Exactly. It's a balancing act between privacy and security.
Got it. Now, VPN technologies can operate at different layers of the OSI model.
The OSI model, yes. It's a way to conceptualize the different functions involved in network communication.
Right. Can you explain, why that distinction is important for understanding VPNs?
Sure. So the OSI model has these different layers, and each layer represents a specific set of functions.
Okay.
And VPNs can operate at different layers, which affects what kind of traffic they protect and how they do it.
Yeah.
For example, you can have a VPN that operates the application layer, meaning it only encrypts traffic for a specific application,
Right.
like, say, Secure Shell or SSH,
Right.
which is used for remote access to a device's command line.
Got it. So it only protects the traffic for that one application.
Exactly, but then you can also have VPNs that operate at lower layers, like the transport layer or the network layer.
Hmm.
And those can encrypt all the traffic passing between two networks, regardless of the application.
So it's like providing a more blanket level of protection.
Precisely.
Okay. A trend towards moving away from those broad network-based VPNs and towards more application-specific ones.
That's right. It's about having more granular control and flexibility.
So why is that shift happening?
Well, network VPNs, while they're simple to set up, it can be a bit too broad.
Hmm.
You're encrypting everything, even traffic that might not need to be encrypted.
Right.
And that can impact performance. You can make it harder to manage.
Okay.
Application VPNs, on the other hand, allow you to be much more selective.
Got it.
You can have a VPN just for your email, another one for accessing sensitive files, and so on.
So it's like a more tailored approach.
Exactly. And it gives you more fine-grained control over your security policies.
Makes sense. Now, finally, let's talk about SaaS.
SaaS, Secure Access Services.
Yeah, it's a mouthful.
It is.
But it's presented as like this more modern approach to network security.
It is. It's really designed for today's cloud-centric world.
Okay, so what's the big idea behind SaaS?
Well, the traditional model of network security, with all those different appliances and services, it's starting to show its age. You've got your firewalls, your intrusion detection systems, your VPN concentrators, all these separate boxes.
Right.
And it's becoming increasingly complex and difficult to manage, especially with everyone working remotely and using cloud applications.
Yeah, that makes sense.
So SaaS is about converging all these functions into a single cloud-delivered platform. It's about simplifying things, making it easier to manage, and providing a consistent security posture regardless of where your users are or what applications they're using.
So it's like taking all those separate security components and bundling them into one cloud service.
Exactly. Think of it as a one-stop shop for all your network security needs.
Okay, and what are the main benefits of this approach?
Well, first of all, it's much more scalable and flexible. You can easily add or remove users. You can adjust your security policies on the fly.
Right.
And it's also much easier to manage from a central location.
Got it.
Plus, it provides that consistent security experience for all your users, whether they're in the office, at home, or on the go.
Okay, so it addresses a lot of those challenges that come with like the modern distributed workforce.
Precisely. It's built for the way people work today.
And identity management as a key component of SASE.
Identity is a crucial part of it, yes.
So how does that fit into the picture?
Well, it's about moving away from just relying on network location to determine access. In the past, it was like, if you're on the corporate network, you're trusted. If you're outside, you're not.
Right.
But that doesn't really work anymore.
Yeah, not with everyone working from anywhere.
Exactly. So SaaS incorporates identity management to verify the user's identity regardless of their location.
Got it. So it's about making sure that only the right people have access to the right resources.
Precisely. It's about adding that extra layer of security based on who you are, not just where you are.
So to summarize, SaaS is about like moving away from this traditional perimeter-based security model.
Right.
And towards a more cloud-based, identity-centric approach.
Exactly. It's about securing access to your applications and data, no matter where they reside or who's trying to access them.
Got it. So we've covered a lot of ground today, from those foundational firewalls to these more modern cloud-based solutions like SaaS.
It's been quite a journey through the world of network security.
It has. It has. And I think, what's really interesting is how all these different concepts and technologies, they all sort of build on each other, right?
They do. They all play a role in creating that layered defense.
Right. You've got your firewalls as your first line of defense. Then you've got segmentation to create those secure zones within your network. And then you've got VPNs to protect your data in transit.
Right.
And then finally, SASE comes in to work it all together to provide a more holistic and adaptable security framework.
It's about securing the modern cloud-based world.
Exactly. So hopefully this has given our listeners a better understanding of the key elements that are protecting our online interactions, our data, our privacy.
And maybe spark some new questions about how to stay safe in this ever-evolving digital landscape.
Absolutely. As we bring more and more devices into our homes and workplaces, as the Internet of Things continues to grow, these security challenges are only going to become more complex.
That's something to ponder, certainly. What are the implications of having all these connected devices, all this data flowing around? How do we secure it all?
Yeah, that's a whole other deep dive for another day. But for now, thanks for listening and stay secure out there.